So good afternoon, everyone. Welcome back to Math 122. Today we are in dark mode, which means that we're doing a review for the exam, which the exam is on Tuesday. Okay, so today is Thursday. So like 4 or 5 days from now, it'll be Tuesday, and that'll be when we have the exam. Okay, so the first exam covers sections 1.1 to 1.9 and 2.1. So in particular, what we learned on Tuesday will not be on the exam. Okay, what we learned on Tuesday will not be on the exam. But everything up to 2.1 will be on the exam. So that's all of the homework assignments that were due up until today. Okay, up until today. So studying for the exam, there's a few options. If you want to study with me, which I recommend, the best way to study is to study with me. The second best way to study is to study with somebody at the Math Tutoring Center or SI. And then the third best way to study is studying on your own. I say, look, if you spend an hour with me, that's probably worth 3-4 hours on your own. If you spend an hour with Math Tutoring Center or Jacob or another SI, that's probably worth like 2 hours on your own. Trust me, having outside help will make your studying more efficient. So regarding that, office hours are from 11:30 to 1 on Thursday, so I already had that one today. I guess the only one that's going to be relevant for the exam is going to be, I'm going to be in the MTC from 10 to 12 on Tuesday. I expect there will be a lot of you there that day because that's the day of our exam. So if you want to have a little last minute review in the morning before our exam, you can come see me there. Also SI sessions, what is there left? 6 to 6:50 tonight. And then the special exam review on Sunday. Do we have a time for that yet?
Yeah, it's going to be from 4 to 6.
Okay, so that's 4 to 6. In where?
Calcott, room 003.
Okay, excellent. Thank you, Jacob. So special exam review session with Jacob on Sunday from 4 to 6 in Calcott 003. So, you know, we've got SI sessions, we've got my MTC hours, and then you can also go to the Math Tutoring Center and go with another graduate student at any of these times. And if you do that for at least an hour, I will give you 2% extra credit on your exam. Free points if you just go study for an hour. Okay, so you just have to get somebody to write you a little note, or if you go to Jacob, he'll send me an email that says that you went, or if you come to me, then I'll just remember. And I'll give you 2% extra credit on your exam score if you make use of one of those resources before the exam. Any administrative questions before we start in on content today? Yeah.
Possible that we reach out to the school to get their temperature here? Because like, it's like 75 degrees out today, and like, if it's into the 90s, I don't think I'll be able to like function.
All right, let me make a note of it.
Thank you.
I'll try, but I guarantee you they won't do anything. Okay, let me write it down. Room too hot.
I think it's kind of necessary.
All right, I'll try.
I can start a petition if you want to change .org.
Could you maybe buy an ice vest of some kind?
I'd have to. I take cold showers. Actually, I don't know. I come here cold, and once I get here, it's hot.
No. Okay, well, in any case, I'll work on that. But any other administrative questions, like specifically pertaining to review/exam/studying? If you don't know how to study for a college math class exam, there's a guide on the syllabus. There's a whole page of how to study for an exam. Go check that out. Mainly, the main thing I would do is redo the homework problems. Because if you know how to do all the homework problems, you'll get an A on the test. Okay? All right. Then let's review. So I'm going to turn it over to y'all. Who's got a discussion topic or a question for me? Braden.
We just go over like Half-Life and
Sure.
that stuff.
Let's do Half-Life and doubling time. Okay, and what do you say? Do we want a formula we can memorize, or do we want to learn the method? Who wants formula we can memorize? And who wants method? Less people want the method, it seems. But we're going to do both, okay. I was just curious to see what you want. All right, so let's take a look at, okay, two different models. We'll look at P naught a to the t. And we will look at, separately, P naught e to the kt. And I'll show you the method by which you can derive the formula. So if you feel like you want to know the method, then you can just see the method. And if you want to have the end result, you can have the end result. It's up to you. Okay, so the first thing we need to identify is what is R? What is R? Question mark. Okay, so, oh, I forgot an equals sign. And P of t equals. Okay, so, okay. Well, specifically, why don't I do something, why don't I do this a little bit differently? What do we want? We want to know the time, t, and when I put a little 1/2 down here, okay, I'm not multiplying t by 1/2. What I'm doing is I'm just putting it as a subscript to say, look, t here is acting as a variable. It could change. T 1/2 is not a variable. It's a specific time, which we are going to search for. Okay, it's a specific time that we're going to search for. We want to know what is that time, such that what is going to be true. Well, if you plug it into the function, then I would get P naught times a to the t sub 1/2. And what do we want that to be equal to? Yeah, P naught divided by 2, or P naught times 1/2, okay? Because P naught is the amount that we start with, okay? P naught's the amount that we start with. So now our goal is just to solve for T 1/2, okay? So I'm going to do that by first divide both sides by P naught. And I get a to the T 1/2 equals to 1/2. And then I'm going to take the natural log on both sides. And now I'm going to use the rule with natural logs, which says, look, if you have natural log of something to a power, the power can come down in front and be multiplied. So that means the left-hand side becomes t times ln of a is equal to ln of 1/2. And finally, I have t times a number is equal to another number. The way I get t by itself is it's being multiplied by something right now. To get rid of the multiplication, I have to divide by that same thing. So I divide both sides by ln of a, and I get t equals ln of 1/2 divided by ln of a. Or if you want, you could rewrite that as ln of 1/2 divided by ln of 1 plus r. So these are your formulas if you want to memorize how to do half-life with this particular exponential function form. Okay, that's how you can get, sorry, I lost my 1/2 at some point. 1/2. Okay? Any questions about that? All right, so now I'm going to show you how to do it with e to the kt, and then I'll give you another formula if you want to have the formula, okay? So we want to know what is the t 1/2 such that p of t 1/2, which is equal to p naught times e to the k times t 1/2, is equal to 1/2 of our amount, original amount. Okay, so just a quick comment. Look, if you don't like this whole business with the P naught, just replace it by some number which you like. Say you have 100 grams of your substance initially. How much are you going to have left after the half-life has passed? Well, you're going to have half what you started with, so you're going to have 50, right? If you want to just put 150 or 1 and 1/2 or whatever numbers you like, you can do that. So you can choose P naught if you want. Anyways, we're going to solve this in a pretty similar way. First, we cancel P naught. We have e to the k times t 1/2 is equal to 1/2. Now we apply natural log. Ln of e to the k times t 1/2 is equal to ln of 1/2. And what happens on the left-hand side? Yeah, I do not need to use the power rule. Okay, I do not need to use the power rule. That is because ln and e are inverses. I can use the inverse rule to say, look, ln of x and e to the x are inverses. These two processes kind of undo one another, and we're left with just k times t 1/2 equals ln of 1/2. And finally, we have our formula. T 1/2 equals ln of 1/2 divided by k. Okay? So, we do not need to know what our original amount P naught is in order to do this process. Yeah?
So for the problems, we would be able to use either or for any of them, right?
Yeah, like I said, these two forms are just a different way of writing the same thing. Okay, just a different form of writing the same thing. That's why we practiced back in the day how to convert between the two, right? So, you know, whether you solve the problem in English or Spanish, you're going to get the same answer, right? So it's different language for the same thing. Just slightly different ways of writing it. So I'm not going to ask you to use one or use the other, but what I may ask is, look, you need to be able to read a problem which phrases the question in one form or the other and be able to find the answer, okay? If you do that by doing the whole problem in one language versus translating and then doing the problem in the other language, it's up to you, okay? All right, so that's the other formula if you want to have the formula for continuous half-life. Okay, so this is continuous half-life, this is annual half-life. And what is the only difference between these formulas and the formulas for doubling time? Can someone tell me?
2.
Yeah, instead of 1/2, we're going to use 2. Okay, so let me copy these and then paste. So for doubling time, all we're going to do is we're going to change the 1/2 to a 2. 2, 2, 2, 2, and 2. Okay, that's the only difference. So when am I going to use half-life and when am I going to use doubling time? Well, it depends on whether your exponential function represents exponential growth or exponential decay, right? If I have a bank account, it doesn't make sense for me to search for a half-life because my bank account is not going down. Well, my bank account's going down, but in terms of interest, if I don't withdraw or deposit, my bank account is increasing, okay? So that's a situation where we look for a doubling time, not a half-life time, okay? All right, so that's half-life and doubling time. How do you feel about that, Braden? Better?
Yeah.
Okay. Any other questions about half-life and doubling time?
Can we give an example with it?
Absolutely. Do you have one pulled up by chance? Does anybody have, what section was that? 1.7 or something like that? You can try to pull up Wiley here. I think it was 1.7.
I have one.
Okay, which one is it?
It's 1.7.
Yeah, which problem though?
Problem 9.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so the last one. Okay, great. So let me write it down and then I'll change the screen. So quantity decreases by 4%. Oh, sorry, 7%. 7% in 13 hours. Find its half-life. Okay, so this is the problem that we want to do. And by the way, if I asked you a question like this on the exam, I would be sure to say something like, you can leave your answer in general terms. For example, no need to compute logs. All right, so let's solve this one together. Okay, well, I'm doing a half-life problem here. So you might think, well, what I want to do is just, use the formula. Tom told me there's a formula that is like T1/2 equals ln of 1/2 divided by ln of A. Can someone explain to me why I can't just go ahead and use this and say, well, I see 7%, so probably it's like ln of 1/2, and since we're doing decay, A would be something like, 0.93. Done. What's wrong with this methodology of solving the problem? Yeah, Aiden.
I guess that's if you don't know the T.
If you don't know the T,
Because it says in 13 hours.
yeah, so here's the problem. The problem is the number which I put in for A, okay, is incorrect. Okay, R is decay rate percentage per hour. We decay 7% in 13 hours, not in 1 hour. If we decayed 7% in 1 hour, then I could just go ahead and do this. That'd be fine. But it's 13 hours. So I can go ahead and still use this formula, but I need to find out what A is. Okay? So let me show you how you do that. So, no. Although that would be an extremely easy mistake to make. Okay, so let's see how we can avoid making that mistake. Well, the first thing I like to do is, look, if you're going to do an exponential decay problem, go ahead and write down one of the formulas for exponential functions. I'm going to use P naught. I don't know, which one should we use? E to the kt or A? Who says A and who says K? Okay, more people for A, so we're gonna do A. But you can do something similar with K. Yeah.
How do you know if the problem's annual or continuous?
It'll specify in the problem, but you can always convert annual to continuous or continuous to annual.
So it doesn't matter.
It really doesn't, no. Unless the problem says something like earns 5% continuous interest. Okay, if it says that, then that's telling you what K is, right? And you have to then convert to A if you want to use the A method, okay? Because a 5% continuous interest rate is not the same as a 5% annual interest rate, okay? Which is just confusing for no reason. but it's not confusing because I made it confusing. It's confusing because the world is a confusing place, and I'm trying to help you understand it. So let's use, we said we were going to use a, right? P naught a to the t. Okay, great. So what do we know? We know that if you plug in 13, how much am I going to have left? Well, I'm going to have 7% left. Sorry, 7% less after 13 hours, which means I still have 93% left. So after 13 hours, you plug in 13 for t into whatever this function is. Then we can determine what is a in the following way, because we know we have 93% of what we had originally. So if you want to say, let's say I had 100 grams, I know after 13 hours I would have 97 grams. That's fine. Or 1,000 grams and 970. Whatever floats your boat, okay? You can come up with your own P naught if you like, or you can leave P naught and recognize that it's just going to immediately cancel. And now we have a to the 13 is 0.93. And so how do I get a by itself? Should I use natural log? Not natural log.
No, just square root.
Square root?
No, 13.
13th. There we go. We made it. 13th root, okay. Or if you want, you can express that as a what kind of power? 1 over 13. Okay, so now we know what a is, okay? So this is the number. Whatever this number is, okay, you could plug it in on your calculator and figure it out. You're not going to have a calculator on the exam, so what I would expect you to do is something like the following. Just write t1/2 equals to ln of a half, and then I need to divide that by ln of a, and I know a is this jazz, so I'm going to put it in. 0.93 to the 1 over 13 power. And that gives you your answer. Okay, so I would say leave it like this. Okay? All right, any questions on that one? Yeah.
How would you do it with the other formula?
With e to the kt? Sure, we can do that. I'm going to go through it kind of fast, just because I don't want to spend too much time on half-life and doubling time, because we got other things, okay? But you can watch the recording if you don't catch it all right away, okay? So P of t is equal to P naught e to the kt. Same deal. I know that if I plug in 13, what do I get? I get P naught e to the 13k is equal to 0.97, no, 0.93 times P naught. Yes? Cancel P naught. Now we have e to the 13k equals 0.93. I'm trying to figure out what is k here. So I'm going to take the natural log on both sides. And then I'm going to get 13k on the left-hand side, ln of 0.93. Geez, I can't write. And then k is equal to ln of 0.93 over 13. And then I'm going to go ahead and use the formula, which if you don't remember it, don't worry. You can always just go back and plug in. In fact, let me show you how to do it. You would say, then I want to know, okay, P of t1/2 I know is equal to P naught times e to the ln of 0.93 over 13 times t1/2, and that's equal to 0.5 times P naught. Cancel P naught, ln on both sides. We get ln of 0.93 over 13 times t1/2 equals ln of 1/2, and therefore t1/2 equals ln of 1/2. I'm going to write it first as an improper fraction, divided by what is k, which is 1. oops, which is ln of 0.93 over 13. Okay, or if you want to bring the 13 up into the numerator, fine. Okay? But what is this really? This is just ln of 1/2 divided by divided by k. Okay, this is ln of 1/2 divided by k. So if you're doing this problem in the A method, you just need to figure out what is A so that you can take ln of 1/2 divided by ln of A. And if you're doing it with the K method, you just have to figure out what is K. And then you just divide ln of 1/2 by whatever that number is. Okay? And by the way, the reason that it's like that in this case and in the other case, it is ln of 1/2 divided by ln of A, is because ln of A is k. Or if you want, A is e to the k for translating between these two different models. Okay? All right, so we got a whole spider web of connectivity between these models and then the half-life stuff, okay? Any further questions about half-life and doubling time or this example before we move on to some new topic? All right, then who wants to give me another topic for review? Yeah?
It's a specific problem, but it's like section 1.5 number 3.
Okay, let me pull it up. All right.
I mean, it's number 3 and 4, but I think I don't.
Okay. Well, you just tell me if this is the one that you're thinking of.
Yeah.
Okay, and then 4 is it something different? Oh, it's something similar. Was there one that had a different point? Maybe not. Okay, we'll do 3 and 4. 2 examples. It's good that you brought this up, right? Because I already told you all that I'm probably going to put one of these exponential through 2 points problems on the exam. I almost always do. So the first one starts at 30, and then it goes down to 49. And we're supposed to write y of t as a function. Yeah. Okay. So here's the problem that we have. Let me write 40 a little better. Okay, so we're supposed to find a formula for this exponential function, okay? So the first thing that you want to do when you're trying to find the formula for an exponential function is just like in problems where you want to find the formula for a line, the very first thing that you do is you write down the general equation of a line, or in our case, the general equation of an exponential function. So when you're trying to figure out what's the equation of a line, I bet that the number one thing that most of you do is the first thing you do is you write down y equals mx plus b, right? We're going to do the same thing here. We're going to write y of t equals, and now what I'm going to write is the general form of an exponential function. Since I'm using y and t, I'm going to use y naught times a to the t. Okay? And now my job is to find out, okay, just like in y equals mx plus b, what am I supposed to do? I'm supposed to figure out what is m and what is b in order to have the equation. But for my problem, I'm going to figure out what is y naught, and I'm going to figure out what is a. Okay? Figure out what is y naught, figure out what is a. But I claim that you already know what y naught is. What is y naught? 30. Because y naught is what you get when you plug in 0, which is to say t is 0. And the t-axis goes left and right. So here's like 1, 2, 3, 4. Oh, sorry. Here's t equals 40. Here's t equals 20. Here's t equals 10, 5. And t equals 0 is right on the y-axis here, okay? So when t is 0, what is the height of the function? It's 30. So you know that y0 times a to the 0 is 30. And a to the 0 is just 1. So this tells you immediately that y naught is 30. Or you can just think of it in a heuristic manner and say, look, y naught is just the starting amount. I know that the start is when time is 0, and I can see that the amount is 30. You can just say that, right? But if you want to see the real, like, mathematical explanation behind it, it can be seen here. Okay, so y naught's 30. Now, someone help me out. I forgot. How do I figure out what a is? Aiden?
You use a point from the line.
Yeah, so after you do math for a while, you start to realize that, look, they give you all of the ingredients that you need to bake a cake, right? And if I'm baking a cake and I already put the eggs in, right? And then I want to know what's the next step. Well, I just look at the ingredients which I haven't used, and I'm like, oh yeah, the flour goes next, right? Okay, so what ingredients have I already used? I've already used up this data point, but I still have more information to play with. It's this data point, 40, 9, which says that, look, the whole deal with a function is that the graph of the function is given in the following way. You take the t value, you plug that t value into the function, and the height of the function is just whatever you get by doing that operation, okay? So we're going to use the data point 49 on this graph, which literally says, look, if you take the y function and you plug in 40, well, I know that's equal to 30, because that's y naught, times a to the, and the way you plug in 40 into this function is you put 40 in the exponent. And what's that equal to? 9. Good. The height of the function is just the output from whatever you get when you plug in the t value. In this case, it's 9. And so from here, I just need to figure out what a is. So, question for the masses. Do I need to use logs? No. Why do I not need to use logs? Or when specifically do I need to use logs? I need to use logs when, what? You've answered too many questions. Someone else. Braden?
And you're searching for t?
Yeah, well, yes, but when t is in a bad place, right? What's the bad place for t to be?
The exponent.
In the exponent. Is t in the or is the thing we want to know in the exponent in this case? No, it's on the main floor. So we don't need to use logarithms here. Okay? What we need to do is just first divide both sides by 30. Okay, if we do that, we get a to the 40 equals 9 over 30, which can be simplified as 3 over 10. Yeah? Now, we verified that we don't need to use logs because we would only need to use logs if the thing we wanted to isolate was in the exponent, but it's not. How do I get a by itself now? Yeah, 40th root, or as a power, the 1/40th power. So 3 over 10 raised to the power 1 over 40. Okay? So, we're pretty much done. We found out what y naught is. We found out what a is. Let's put it all together as an equation. Y of t equals 230 times 3/10 to the 1 over 40 to the t. Okay, so this would be a way that you could answer this question on the exam without using the calculator, but I'm not going to make it this annoying in terms of all these fractions and stuff. I'll make the numbers work out a lot nicer than that, okay? But you need to know things like the cube root of 8 is 2, the cube root of 27 is 3. Those would be good ones to know. Yeah, question?
Could we do one where we don't have P naught?
Yes. Can we do one where we don't have P naught? Well, I have a question. Are there any homework problems where that happens? Because if not, then it might not be useful to do. Yeah, I think I messed up and I forgot to include a homework problem where you're not given P naught right off the bat. Yeah, that one gives you P naught as well. Yeah, I don't think there's any problems where you don't have P naught.
There's
So
one with like you're using a table. I know that's different than a graph, but it's still 2 points. Like instead of just like it giving you P naught, you'd have to use 2 different points. I'm pretty sure one of them gives you a table. In that one.
okay. Can you work on pulling it up?
Yeah. I could try.
Yeah, so I'm gonna say I'm gonna not do that for now, just because I don't want to spend time on the review doing something that won't show up on the exam. Next topic, or a question coming from the homework. Did you want to do the other one, Elena? Number 4. Let me look. Number 4 is essentially the same, but it won't take very long to do. This goes from 0 to. We'll do it real quick. And I'm gonna explain less. Sometimes I feel like if you explain too much, then it becomes almost more confusing than it is otherwise. So I'll do this one in a faster method. Maybe more similar to what you would actually do on the exam. Okay, well, I know that P of t is equal to P naught times a to the t, and in fact, I already know what P naught is, so I'm just going to quickly replace that by 2. So I know this is the general form of this function, and I know that's used up the information out of this data point. I still have the other one left, so I know if I plug in 2, I'll get 8. So I'm going to go ahead and do that. P of 2 would be 2 times a squared, and that would give me 8. And then I just divide both sides by 2 to get a squared equals 4, and therefore a has to be 2, because a has to be a positive number for us to have exponential growth. And therefore P of t is equal to 2 times 2 to the t. Okay? That's sort of like a faster showing of that solution. Okay? Did you find the one that you were talking about? Okay, that's fine. Take your time. All right, sorry. There was something else somewhere over there. Lena, you got one? Number 9 on 2.1. I sure can. All right. Is that it? Ah, okay. Yeah, we want to see this one? Okay, so I'm going to write it down. It says find average velocity between t equals 1 and t equals 1 plus h if S of t is 3t squared plus 2. And h equals 0.1, h equals 0.01, and h equals 0.001. And then estimate s prime of 1, or the actual velocity when t equals 1. Okay, let's do it. So, here's the basic picture of this problem. Let's draw it. We know what a parabola looks like. I know what a parabola looks like. And this parabola is stretched by a factor of 3 and shifted up 2 units, but otherwise it's centered, right? So it's going to look something like that. Oh, that's a pretty good parabola if I don't say so myself. And then we're looking at t equals 1 and t equals 1 plus h. So we're doing average velocity over several different intervals. The first interval will be from a equals 1 to b equals 1.1, because b is 1 plus h. The second interval will be from a equals 1 to b equals 1.01, and then we'll have a equals 1 to b equals 1.001. Okay, so I'm going to draw this in an extremely exaggerated fashion to illustrate my point of what we are actually doing here. So imagine, this is totally not to scale, but imagine that 1.1 is over here, okay? It's just somewhere to the right. The average velocity is the slope of the line which passes through these 2 points. Okay, that's the average velocity for h equals 0.1. And let me show you what it looks like when we do h equals, say, 0.001. Okay, so here's 1.001. And that average velocity for h equals 0.001 looks like the line, looks like the line which goes through these 2 points. And what am I ultimately trying to do? In the end, what I want to do is estimate the slope of this tangent line. Okay, so this is the slope of the red line. The average velocity, or average rate of change, is the slope of that red line. And then we're going to do the slope of the pink line. And we're going to check. Well, you can see that the slopes of these lines seem to be getting closer and closer to the slope of the line that I actually am interested in. Okay, so this is where we're going. Are there questions about, like, the heuristic idea behind this process? Okay, so let's go ahead and do it. At the end of the day, I mean, I suppose to solve this problem, you don't really need to understand this picture. All you need to know is how to do average velocity, which average velocity is just average rate of change. And I think for a lot of people, what's tripping them up is what is with this h business, right? What is with this h business? But look, you just they tell you what h is going to be, you put it in, and then you find the average velocity between t equals 1 and t equals 1.1, okay? That's all we're doing. So let's do it. Well, I know that the average velocity will be s of b minus s of a over b minus a, which in this case is 3 times 1.1 squared minus 3 times 1 squared, oh sorry, plus 2. And then I'm going to subtract 3 times 1 squared plus 2. And then I will divide by, oops. I will divide by 1.1 minus 1. Yep. Okay, so what do I get when I do that? 1.1 squared is 1.21. These guys cancel, so I get 1.21 times 3 is 6.61 or something like that. 6.61 all over, sorry, 6.61 minus, what the hell am I doing? 3.61, right? (3.61) minus 3 all over 0.1. So I'm getting 6.1. Is that right? How do we get 6.3? Have I made a numerical mistake here? 1.1 squared.
Yeah, it's 3.63 when you 1.1 squared is 1.2.
Oh, I forgot to do the freaking 3. That's why. Thank you. 6.3. Okay. So I just typed it in wrong, or I did the calculation wrong. Okay. So there we go. 6.3. And now what is left to do is just to repeat this process, but with smaller, using 1.01 here. Okay. And then I'm going to use 1.001 here. Okay, so similarly, then we get 6.03, right? And then again, similarly, proceed similarly. We get 6.003, something like that, right? Okay, so what is this really telling us? This is telling us in terms of this picture, look, I did some of these slopes. This slope was 6.3. This slope was 6.03. This slope is 6.003. And then you want to know, what is this slope gonna be? Well, based on our understanding of how this process is going, you could imagine what it would be like if you kept adding zeros and you did b equals 1.0000001. What are you going to get? Well, you're going to get 6.000000003, which is even closer to 6, right? So this number is getting closer and closer and closer and closer to 6. Okay, so estimating this, I would say best guess, S prime of 1 equals V of 1 equals 6. Is that what they put here? Yeah, okay. Oh, and they even say to the nearest integer, so it's definitely going to be 6, right? Okay, so how do we feel about that one? That one's a little bit trickier. What's the hard part on this one? Very qualitative, personal question. I'm just curious. What's the trickiest part of this one?
I got mixed up when I was like dividing. Like you divided 1.1 by or minus 1.
Mm-hmm.
I didn't know what to put there. It took me a minute.
Yeah. Okay, so it's kind of weird. On the bottom we got B minus A, but B is like almost A, right? So we end up with like these small numbers on the bottom. That's by design because the top is also becoming much smaller, right? As we move from case to case. What else was kind of annoying about this problem?
a lot of work.
Yeah, it's kind of a lot of work. You got a lot of steps. And also, the part that I think is annoying too is the way they say, okay, find the average velocity between t equals 1 and t equals 1 plus h. And you're like, what does that mean? But then later they tell you what h is going to be. So it would maybe be easier if they said find the average velocity between, and they got rid of this part, and they said, got rid of this part, and they said a equals 1 to b equals 1.1, a equals 1 to b equals 1.01, you know, and a equals 1 to b equals 1.001. That would make it a little bit easier, because it's just kind of like taking up less mental space in your brain to sort of figure out, like, what exactly am I doing here, okay? But all we're really doing is just taking h and plugging it in here and sort of rewriting the question so that we understand, like, oh, okay, I'm supposed to find the average velocity over this specific interval. Okay, final questions on this one before we move on to something else? All right, doesn't seem like there are any, so next question? Yeah.
Can we try number 11 on 1.4?
Absolutely. Number 11 on 1.4. Is that like the last one or second to last?
That's the very last one.
Very last question. Okay, great. That makes it easier for me. All right, so this was a quiz question, right? I think. Shirts. Fixed cost. 7,000. Variable costs. $2. Shirts. Oh my god. Shirts sold for $10. Find cost, revenue, profit, functions, and we'll start there and we'll come back to this. Okay, sure. Yeah, we'll start here. Okay, so we have a fixed cost, we have a variable cost, and they tell us how much we sell shirts for. Okay, and our goal is to first just write down what are the cost, revenue, and profit functions. Okay, so we're starting simple, just trying to come up with a function which takes as an input, okay, takes as an input Q, which Q represents quantity of items sold. And we're going to assume that we produce exactly as many items as we sell. Okay? Maybe we produce them on demand or something like that, right? So, let's come up with the cost function. So the cost function should take Q as an input, and the output should be the cost of producing Q shirts. Okay? So $7,000 is our fixed cost. What could that represent in terms of this problem?
Initial cost.
Yeah, initial cost of like what for a business? What might be a fixed initial one-time cost for a business?
Like the building itself?
Yeah, maybe the brick and mortar place itself, okay, or the factory, or the machinery needed to press the t-shirts, or whatever, okay? So that's a one-time payment. So that's the reason why I don't attach a Q to it. Okay, because if I attached a Q, then for each time that the number of shirts I sell goes up by 1, our price would go up by 7,000. We know that's not right. We're not paying 7,000 per shirt, paying $7,000 one time. But I am going to have an additional term because after I get all the equipment, I still have to pay for like the materials, the fabric, in order to make the shirts. And they say that that costs $2 because that's our variable cost. Variable cost always is attached to the variable, okay? Variable cost is being multiplied by the variable. That's why we call it variable, all right? So that's how we get the cost function. And now we want to do the revenue function. What's my revenue function going to be? Yeah, 10Q. Let me ask a business question. Why don't I have a fixed revenue? I have a variable revenue, but I don't have a fixed revenue. Why not? I heard a mumble. What was it? Why don't I have a fixed revenue?
You don't know how many you're trying to sell.
I don't know how many I'm gonna actually sell. That's correct. And moreover, what happens if I sell 0? How much revenue do I get? 0. So you could think of it as saying, well, I do have a fixed revenue, it's just 0, right? Fixed is like what you have to accomplish, okay, either cost or revenue or profit wise, okay, if you sell exactly no shirts, okay? Another way to think about that is that the fixed cost is the intercept, the y-intercept, or the vertical intercept of your cost function, okay? It's what happens when we plug in 0 for Q. We get 7,000, right? If you plug in 0 here, we're left with just 7,000, yeah? Okay, so how do I get the profit function from the revenue and the cost?
Subtract.
Yeah, just subtract the costs from our revenue. And that's easy enough. So follow me closely here. I'm just going to put 10Q. And then, of course, I just need to subtract the cost. So that would be minus 7,000 plus 2Q. So we combine the Q's to get 12Q minus 7,000, right? No. Okay. I couldn't fool you. What did I do wrong here? Should I do costs minus revenue instead? Not quite. But something's a little fishy here. What's fishy? Aiden?
The 2Q is part of the cost, so it's got to be negative.
Yeah, Aiden hit the nail on the head. I'm supposed to subtract the costs. This is my costs. But I didn't subtract the costs. I subtracted the variable cost, but I actually accidentally added. Sorry, I subtracted the fixed cost, but I accidentally added the variable cost. Okay? So when I subtract a whole last thing like this, I gotta subtract the whole last thing, which means I have to distribute the minus onto both of these, okay? So I have to be a little bit careful, and the way you can check is, look, you know that if you're paying $2 for every shirt and you're making $7 for each shirt, realistically, you should be making $5 per shirt. If you see 12 and you're like, not 5, Jesus, I meant to say you're making 10 off of each shirt, right? And you're buying them for 2, that means I'm making $8 per shirt, not $12 per shirt, right? So this should actually be 8Q here. Okay, 8Q, that's how we combine those. All right, so now we have the profit function. Okay, and what would I do if I wanted to find the break-even point?
What is 7,000? Why is it plus 2Q? Oh, it's just.
Because the cost,
No, I got it.
yeah, the cost is 7,000 plus 2Q because it cost me $7,000 plus $2 per shirt. Any other questions before we do break even? All right, how do I find break even point?
Set it as 0.
or break-even quantity. Yeah, I'm just gonna set the profit function equal to 0. Or if you want, you can set the cost function equal to the revenue function. That's the same thing, right? Because if these two things are equal, we subtract something from itself, we're definitely going to get 0, right? So we want pi of q naught, which is gotten by doing 8 times q naught minus 7,000, and we want that to be 0. So then we would solve that for q naught by adding 7,000 to the other side and dividing by 8. Questions on that? Yep.
Can you set them to again? Like you said you could set the cost and the revenue to each other?
Yeah, so this is setting profit equal to 0. So this is pi equals 0. The other way to do it is to do r of q naught equals c of q naught if my revenue is the same as my cost. But this is the exact same equation. It just says, look, r of q naught is 10 times q naught, because I make $10 per shirt, and c of q naught is 7,000 plus 2q. Do you see why this equation is exactly the same as this equation? Because if you take the bottom equation in blue and you move everything to the left-hand side, then you get the profit function above. I dropped a naught, but yeah. If you take all this to this side, then you get 8q naught, because you combine like terms, minus 7,000 equals to 0. All right? So you can solve that instead if you want. It's the same exact procedure. Any other questions on break-even quantity? Okay, now let's go to the hard part. What is the hard part? The company is considering changing the selling price of the shirts. Okay, the selling price of the shirts. So, in particular, we are now no longer working under the regime of... So, okay. We are changing the price. Okay, we are changing the price. So now we're no longer working under the regime of R of Q equals to 10Q, because that was when we were charging $10 per shirt. Now we're not going to do that anymore. Now R of Q is question mark times Q. Or if you want, you could say it's P times Q, where P is the price that we're going to choose, okay? P is the price that we're going to choose. And what is that price going to be? Well, they tell us that they tell us that the demand function, so the demand, what is it, Q equals 2,000 minus 40p. And they want to say how much is sold at $10 price, and what is the associated profit. Okay, so let's quickly review what demand is. Well, demand is a different sort of function, okay? Usually with the cost, revenue, profit function, the input is the amount that we sell, the amount of units that we sell, and the output is the amount of money that we have to pay or get paid or make overall as a profit. For a demand function, it's just the opposite. The input is no longer the number of units. The input of the demand function is the price, and the output is the amount of units which people want to buy. Okay? Like if I set or if not I, but if Tim Cook sets the new Apple iPhone price to be $1 billion, how many people do you think are going to buy the new Apple product? Probably one, Jeff Bezos. Just to do it, right? Just to flex his cash. So, but if we set the price of the new Apple iPhone to be like $1,000, then suddenly people think it's worth it depending on, their financial status, right? There goes the iPhone now. Okay, so that's what's going on with the demand function. So we can understand sort of how much money we are going to make by understanding, well, what am I going to set the price? How many people are going to buy it at that price? And then we take how many people will buy it at that price, multiply it with the price itself. That will give me how much revenue I make. Okay? So that's kind of what's going on here with the demand function. But let's see here. How many, what are we selling here again? Is it shirts? Yeah, okay. How many shirts are sold if we set the price to $10? Well, we know that Q is equal to 2,000 minus 40 times whatever we set the price to be, which the price we're setting right now is 10. So this is 2,000 minus 400, which is 1,600 shirts. So that's how many shirts we're going to sell. And now we want to know, what is the associated profit? Well, we know the profit is equal to revenue minus costs, which in our case, the revenue is going to be 10 shirts times the however many we sell, which is 1,600 shirts, minus 7,000, that's our fixed cost, plus $2 per shirt, which we made 1,600 shirts, so that's our variable cost. So if we multiply this out, we get 16,000 minus 7,000 plus 3,200, which is 16,000 minus 10,200, which is 5,800. Yes? Okay, so now we can see, look, the profit we make is sort of indirectly a function of the price which we set, because the price determines how many will be bought, and the price plus how many times how many are bought determines how much revenue we get, and then we just subtract our costs to get our total profit. Questions up to now? Okay, let's make it a little bit more concrete with part C. Okay, so part C says, let me write it down. Use demand function to write C, R, and pi as functions not of Q, but of P. Okay, so this is the trickiest part. Am I out of time? No, I got 5 minutes still. Okay, so we want to use the demand function to write C, R, and pi as functions of P. So let me remind you that Q is given by 2,000 minus 40P. Well, I already have functions for cost, revenue, and profit in terms of Q. And now I have Q in terms of P. Q in terms of P. So I'm just going to write the cost function as I know it. The cost function is, what, 7,000 plus 2Q. And I know what Q is in light of the demand function. It's 2,000 minus 40p. So I'm going to write 7,000 plus 2, and I'm going to plug with parentheses like I always do. And then I'm going to solve that out. 7,000 plus, well, there's nothing really to solve, right? 7,000 plus 2,000, plus 4,000 becomes 11,000. And then minus 80p. And what about the revenue function? And here's where I think a lot of people got tripped up. A lot of people thought the revenue function was 10Q, wasn't it? But remember, that was only when we were selling shirts for $10 a piece. If we want to actually know the revenue function in more generality, if in case we change the price to something else, what it really should be is not 10 times Q, but P times Q, where P is the price that we pay, okay, or that we charge. So now I just replace Q by what it is in terms of P again, and I end up with P times, what is Q? 2,000 minus 40p, which is, of course, 2,000p minus 80p squared. And now how can I figure out the profit function?
Why is it 80p squared?
Sorry, I just copied it down wrong. It should be 40p squared, right? Thanks. All right, finally, how do I get the profit function? Do I need to go through this whole process over again with the profit function? No, I can just take the costs, I can take the revenue minus the costs. So I get 2,000p minus 80p squared minus 11,000 minus... Jesus, I miswrote it again. Sorry. I'm so bad at that. Okay. Minus 11,000 minus 80p. And so now we end up with what? Minus 40p squared plus 2080p minus 11,000. Okay, minus 11,000. And what kind of function is this? This is a quadratic function. Does it open up or down?
Down.
It opens down because the leading term is negative. In fact, you can make a pretty good guess on what this thing is going to look like by thinking, well, what's it going to be when I plug in 0? It's going to be negative 11,000. And then I'm going to go up, and then I'm going to go down. Probably that's what's going to be going on here, yes? So if I want to, say, maximize pi of p, what do I need to do? I need to find the point at which the profit is biggest. The point at which a parabola which opens down is largest is the vertex. Yes, the vertex. So Q, sorry, not Q, but P, the price we should set should be negative b over 2a, which is where the independent variable of a vertex of a quadratic lives, which in our case will be negative 2080 over negative 80. Okay? All right. We'll stop there for today. Good luck studying. Don't forget I have MTC hours. There's Jacob's SI session. Lots of opportunities to study. Don't panic. You're all going to do great.